Okay, so in this video we're going to look at some math problem based on this SIR model, and it will be very useful for you for your exam. Okay, so let's do this problem. Consider the rubella disease that typically lasts for 11 days. A city of 30,000 people is exposed to this disease, wherein a person is on average in contact with 6.8 other people. Let S of 0 be 29,000 and I of 0 is be 1000. So R of 0 is 0 and these two add up to 30,000. Okay. Determine the number of people who are infected in the next 2 days. Okay. So what we need to find is this I of 1 and I of 2. The number of people will be infected on day 1 and on day 2. Now the contact rate parameter C is given by B times R divided by S. So if you go back to the second video, so the contact rate C is B times R over S. Now B is the average total number of contact a person can have, and 1 over R is the average number of days a person will be sick. So B is given as 6.8 and R is 1 over 11, because 1 over R is 11, so R is 1 over 11. So 6.8 times 1 over 11, B times R, which is 1 over 11, divided by the number of people who are susceptible for the disease, which is 29,000. So that will come out to be this value. Now the recovery rate parameter R is 1 over 11, which is this. So d or S of t over dt is given by this equation, di of t is given by this equation. Now S of 1 is basically S of 0 minus this. So this is how the susceptible people, the rate at which the number of susceptible people over time will change. So S of 0 minus C times S of 0 plus times I of 0. So all this we have the values. S of 0 is 29,000, C we just found out, and then S of 0 times I of 0. And do the math, you get 28,382. So this is the number of susceptible people at the end of day 1. Now the number of people who are infected at the end of day 1 is going to be number of people who are infected on day 0 plus this C times S of 0 times I of 0 minus R times I of 0 plus. So this is the rate at which the infections is growing. So that's what we have here. So it is 1000 as I of 0 plus C times S of 0 times I of 0 minus R, which is 1 over 11 times I of 0. So you do the math, you find out 1527 is the number of people who are infected on day 1. Now S of 2 is S of 1 minus C times S of 1 times I of 1. So plug in the values. S of 1 is 28,382 minus C times this is S of 1 times I of 1, and that you're going to get 27,458 as S of 2. Now I of 2 is I of 1 plus C times S of 1 times I of 1 minus R times I of 1. So plug in again all the values. I of 1 is 1527 plus C times S of 1, which is 28,382 times I of 1 minus 1 over 11 times I of 1, which is 23,112. So that's the number of people who will be infected on day 2. Okay, now another problem. Consider an epidemic that will make a person to stay infected for 6 weeks. A city of 30,000 people is exposed to the disease, wherein a person is on average in contact with 6.8 other people. At S of 0 be 29,000. Find the maximum number of people who will be infected at any time. So this is the maximum number of people who will be infected at any time. So N is 30,000, S0 is 29,000. So all we need to find is Q, and Q is C over R. So we need to find C. R is given as 6 weeks. Now, not 6, 1 over R is given as 6 weeks. Alright, so R is 1 over r is 6 weeks. Now we'll convert the weeks to days. So r is 1 over 6 times 7, which is this. So this is going to be b times r. So b is 6.8, the average number of people you are in contact with, times 1 over 6 times 7, which is r, b times r, divided by 29,000. So that's what is this number. So again, this is b times r, and r is 1 over 6 times 7. Okay. So it's going to be 39,000, not 39, 30,000 minus 1 over this, so q. So once you find c over r, q is c over r, c is this number divided by r, which is which makes q to be 0.000235. So substitute the value of q here and S0, you get the basic reproduction number to be 6.8, and that's the q times S0. So 30,000 minus this is 1 plus log of 6.8 divided by 0.000235, and if you do the math, you get 17,561. So out of 30,000 people, the maximum number of people who will be infected at any time is going to be 17,561, and the basic reproduction number is going to be 6.8. Okay. Alright. Now another problem. Consider a set of population 3 million, and that 60% of this population is initially susceptible to a disease. The rest of the population are immune to the disease. Determine the basic reproduction number for the disease, which could be anywhere from 1 to 5. Okay. Okay, let me do this problem in another video.